Alright, we're going to be looking through 4 different questions on linear and simultaneous equations. The first one involves quantities of bread and milk. And we've got 8 loaves of bread, 5 liters of milk for $21.40. Later on, 6 loaves of bread, 9 liters of milk for $23.40. So they've defined the variables for us. They said B is the price of the bread, M is the price of the milk. And they've written down the first equation for us. 8 loaves of bread, that's right there, 8 times the price of each loaf of bread, and 5 liters of milk, that's 5 times each liter of milk, is going to be a total of $21.40. And so part A says that we need to write an equation in B and M for Thursday's sales, which is 6 loaves of bread, so 6 times B, which represents the amount of each loaf of bread, plus 9 liters of milk, so 9 times M, the quantity, is going to give us a total of 23.40, or I can write that as 23.4. Alright, in part B I need to find the values of B and M. Effectively I've got a system of equations here. My first equation was 8B plus 5M is 21.4, and I've got 6B plus 9M equals 23.4. Quickest way to solve a system of equations that's already been written in standard form like this is to go to PolySimilt. So let's go to our app called PolySimilt 2, and of course we want to go into option 2, which is the simultaneous equation solver. We have 2 equations, 2 unknowns, but I'm going to change my answer to decimal format because it's going to be money, and money is expressed as decimals, as we find B and M are the prices, so those are going to be decimal values. So let's put in the values then. We've got 8 and 5 for a total of 21.4 on Tuesday, and then we've got 6 loaves of bread, 9 liters of milk, and 23.4 is going to be the amount for Thursday. And now we'll press solve, that button right there, and it tells us that the first variable, x1, which corresponds to our B, is equal to 1.8, and so in dollars, of course, I have to add a 0. So 180 for a loaf of bread, and 140 for a liter of milk. And no work is required here. I just read something on the IB syllabus that says that when you are solving a system of equations, you never need to show any work. In fact, IB expects you to use PolySimilt to solve it. Part C, this is the one that a lot of you had difficulty with, was drawing a sketch of these 2 functions. You'll notice that M is on the vertical axis, so let's think about that as the y. B is on the horizontal axis, so let's think about that as x. So if I rewrite this system of equations in terms of x and y, we'd have 8x plus 5y is 21.4, and 6x plus 9y equals 23.4. I would love to put these into the calculator as graphs, which would mean that they'd be in the y equals feature. In other words, I need to isolate y in each of these 2 equations. Alright, in the first equation, my 5y will be equal to negative 8x as I bring the 8x across to the right, plus 21.4. And in the second equation, it's 9y is equal to negative 6x after I bring it across. And lastly then, if I'm going to get y alone, that means I'm going to have negative 8 over 5 if I divide both sides by 5, and of course the 21.4 is also being divided by 5. In the second equation, let's call it y2, I've got negative 6 over 9, and I've got 23.4 over 9. So let's enter these quantities into the y1 and y2. First one, negative 8 over 5x plus 21.4 over 5. And the second one is negative 6 over 9x plus 23.4 over 9. And now I've entered my 2 equations. I'm going to press graph. There's my first equation. Let me look at my syntax and see whether I entered something wrong. Oh yeah, alright, I've got to insert a 6 in here that didn't register. So insert a 6. Alright, let's try that again then. There's the first equation being graphed, and here comes the second equation, and we can see where they intersect. Now I'm supposed to be able to copy a sketch of this graph onto the paper. You'll notice that in the y direction, my window goes from 0 to 5, while in the x direction, my window goes from 0 to 4. So let's go over to window and just get some matching windows. My x min is 0, my x max is 4, and then my y min was 0, and my y max was 5. And now let's graph again and just copy a sketch of what I see. So the first one went from just above 4 and came down between 2 and 3. Oops. And the second one started between 2 and 3 and came down all the way to around the end. And they intersect right here. In order to find that intersection point, I'll say second trace to go into the calculate menu, and then I'll come down to option 5, intersect. It asks me what my first curve is. Yes, that's it, y1. It asks me what my second curve is. Yes, that's my other system of equations. So enter, and then it wants me to guess. Let's move the cursor close to the intersection, hit enter, and it tells you what we already knew, that x is equal to 1.8 and y is equal to 1.4. In order to show the work, I'm just going to label that point of intersection, and I will also label each of these lines. So this first one was negative 8 over 5x plus 21.4 over 5, and the second one, y2, was negative 6 over 9x plus 23.4 over 9. Let's move on to question number 2. Alright, Mal is going shopping. He's got 50 tins of beans, 20 packets of cereal for a total cost of 260 Australian dollars. Now if B is the cost of 1 tin of beans, and he's got 50 tins of beans, well then 50 times the cost of 1 tin of beans would be the total amount of money spent on the beans. Plus 20 times, and we're using, I think, C to be the cost of 1 packet of cereal, and that gives us a total of 260. Alright, Stephen thinks Mal has not bought enough, so he goes and buys 12 more tins of beans. So that's 12 times the beans. And he got 6 more packets of cereal, 6 times the cost of a cereal packet, and he paid 66. Now we have to find the cost of 1 tin of beans. Quickest way to solve this will be putting it into a system of equations. So let's go into Simultaneous and enter those values. So system of equations, yes, that's fine. We do want the answers as decimals because we're looking for the costs, and those will be expressed as decimals. And I'll just clear these and rewrite them. So I've got 50, 20, and 260. And I've got 12, 6, and 66. Alright, solve. It tells us that the cost of 1 tin of beans, which is B, is equal to exactly $4. And then it wants us to sketch the graphs of these two equations. Much like I did on the previous problem, I'd need to think of these in terms of x and y, and I'd need to rewrite them in terms of y. I'm going to skip a couple of steps. You can refer back to question 1 if you want to see how that's done. But our first equation, once you've isolated the y, you'll end up getting negative 5 over 2x plus 13. And in the second equation, once you've isolated y, you'll end up getting negative 2b, or 2x in this case, plus 11. And so if we put both of those in to our, let's quit. Alright, if we put these in as y1 and y2, let's see what we get on the graph. So negative 5 over 2x plus 13, and, oops, darn, wait a second, I missed my 3. Alright, plus 13, and the second one, negative 2x plus 11. Alright, let's graph those. I'm going to change my window right now to a standard viewing window because I'm not really sure where they're going to intersect, so that was zoom 6. And it resets the default window from negative 10 to positive 10. There, I can see my point of intersection, so if I was going to sketch the graph, I can see that one comes down like that, and the other one comes down very similar, and they intersect right there. I should probably label each of these. And let's find the intersection point. Second calc intersect. And then because these are the only two y's entered, I can just go enter, enter, enter 3 times, and it shows us the intersection point at 4, 3. And there we go. Let's move on to question number 3. Alright, a plumber charges $90 per hour for work, plus a fixed cost. Now if this is the equation, glitch, just wait for it, it sometimes does this. Okay, well, let's redraw it. We can see the $90 per number of hours that he's working right there. The fixed cost that he charges just to show up must be the 60 Australian dollars. Part B. Takes 3.5 hours to complete a job. So they've given you the value of t, so the cost is going to be 60, the fixed cost, plus $90 being charged for each of the 3.5 hours. And if you resolve this, you will get 375 Australian dollars. It's pretty good money for 3.5 hours work. Part C. Steve received a bill for 510. This time they've given you the cost. So 510 is equal to 60 plus 90t, and we're trying to figure out what t is, the amount of time it took the plumber to complete the job. Let's bring 60 to the left, and we now have only 450, and now let's divide both sides by 90, and we find out that t equals 5 hours for the plumber to complete the job. And question number 4. 10,000 people attended a sports match. We've got X adults and we've got Y children. Well, that must mean that the number of adults plus the number of children is equal to 10,000, all of the people who attended the sports match. Now, the cost of an adult ticket is $12. So the total amount of money that's been received for our X adults will be 12 times X. That's how much money we received, $12 for each of the X adult tickets sold. Similarly, we have $5 received for each of our child tickets sold, and that gives us a total, I'm solving the next question. Let me back up a bit, sorry about that. First I've got to just find out the cost of a family of 2 adults. So 2 adults at $12 each, 3 children at $5 each, and that gives you a total of $39 for the whole family to attend the sporting event. Alright, part C. This is what I was just doing a moment ago, is that we've got $12 coming in for each of the X adult tickets, and then we've got $5 coming in for each of our Y child tickets being sold, and the total amount of money coming in is $108,800. And most of these word problems that require a system of 2 equations are going to end up having one equation which is written out in terms of the number of items, in this case the number of people, and the second equation will probably be the amount of money from the first item, the amount of money collected from the second item, and the total amount of money. This is true in those coin problems as well. If you had, say, 10-cent coins and 5-cent coins, we'd need to multiply the number of each types of coins by their respective value in order to get the total monetary value of the collection of coins. Now we just need to figure out the value of X and Y. We've got a system of equations. Let's put them into polysilt. Two equations and 2 unknowns, and because X and Y represent a number of people, we expect them to be integer answers, so it doesn't matter whether I have them as decimals or fractions. Let's clear the previous system, and then we've got 1X, 1Y, and 10,000 people attending a sporting event. And then the costs of each one, the adult tickets cost 12, the child tickets cost 5, and the total amount of money that came in was 108,800. And once we've entered that equation, we'll solve and find out that we had 8,400 adult tickets were sold, and there were 1,600 children who attended the event.